Hello, in this video we're going to look at the classic collision question where you just got a couple of spheres rolling around hitting each other. So let's see if there's anything in the question that isn't in the diagram. Smooth uniform sphere A, emphasizing smooth all the way through this. Mass M, that's there. Moving 8U, that's there. Straight line on a smooth table. Smooth sphere B, mass 4M, that's there. Moving with U. Right, so all of that is in that picture. So that's our setup that we got at the beginning. Sphere A collides directly with sphere B. So everything's moving in the same straight line is what it's saying here by directly. And of course it is because it's moving faster when it's behind it going in the same direction. Coefficient of restitution is E. So we have to find in terms of U and E the velocities of A and B immediately after the collision. So we've got our two usual collision things. We'll start with our conservation of momentum. What's our momentum beforehand? We got an 8 mu and we got a 4 mu. So we got 12 mu. That's our momentum before the collision, which has got to be the same as the momentum after the collision. Let's come up with our signifiers for velocities after collision then. So we'll have an mv subscript A and a 4mv subscript B. So we have to work out VA and VB for this part of the question. Then we got the coefficient of restitution. So coefficient of restitution is the speed of separation divided by the speed of approach. Speed of approach, that's dropping B down to 0 before the collision. So we're taking U off. So we got 7U. And if we multiply that 7U by the coefficient of restitution, then we get the separation speed. So the separation speed is going to be the thing at the front, VB, minus the thing at the back, VA. That's what they're going to be separating, the separation speed after the collision. So we've got two equations, 4 unknowns, but we're allowed to leave 2 of the unknowns in the answer. So we're fine there. We've got 2 equations for the 2 things we want to eliminate. We just need to solve these things. In the first one, we can get rid of all these m's for a start. They all just cancel out, as we're always, or usually happening in these conservation momentum questions because of how they set them up. So we've got VB is equal to 7UE plus VA from the bottom equation, and that is going to be equal to 12U minus VA all divided by 4. So we can solve this top one and then, well, yeah, solve this for VA. That's one thing we're going to get out of this. So let's multiply everything by 4. 28UE plus 4VA equals 12U minus VA. So 5VA is equal to 12U minus 28UE. So what factor have we got in all of those? Well, we can certainly let's pull a 4 out. So 4U times 3 minus 7E all divided by 5 at the end, just to save some space, is giving us VA. So that's given us our VA. And now VB, well, we just need to plug this in. It might be easier just going back to the start on VB. Yeah, let's go back to the start on this one, because I think we'll just maybe end up with a mess. No, let's stick with it. Let's sub back in. So VB is 7UE plus this VA that we've got here. So let's multiply everything by 5. So 5VB, that'll become a 35. And then we just have to put on our add on 12U and take off 28UE. So VB is going to be equal to, we've got 7 lots of UE. So take the U out. So 7E plus 12 divided by 5. So that's given us VA and VB, which is our first part of the question. Direction of motion of A is reversed by the collision. Show that E is greater than A, where A is a constant to be determined. So we're looking at this thing here. This is the velocity of A after the collision. So if the direction of motion has been reversed, this has now got to be negative. So yeah, this is just saying that VA is less than 0. In which case, well, we know U is positive. We know that E is positive here. The only thing that can make this negative is the 3 minus 7E is less than 0. So we've got, let's just section that bit off. So we need 3 minus 7E is less than 0. So E is going to have to be greater than 3 over 7. E has to be greater than 3 over 7. Right, that was fine. Subsequently, B collides with a fixed, smooth vertical wall. All right, so we've got a wall over here. Right angles to direction of motion. Coefficient of restitution is, so E is 2/3 when it goes off of there. And then B collides again with A after rebounding from the wall. Show that E is less than B, where B is a constant to be determined. Okay, so when B hits the wall, so we've got the velocity of A when it's moving the other way. We already know that. So B's got to hit the wall, then it's got to turn around, and it needs to now be going quicker. It needs to have a greater magnitude than the velocity of A. Right, so that should be okay. So when B hits the wall, so it's going to be 2/3 of VB, and let's take the magnitude of it because that's all we really care about, and that's got to be greater than the magnitude of VA, in which case it will then catch up and hit VA again. Okay, so 2/3 of VB, fair enough, 2/3 of VB. Well, if we don't put in the minus sign, because when it hits, it will get a minus sign multiplication because it's changing direction. So we can leave that minus sign out, and then we know it's still going to be positive. So we just got to do 2/3 of VB. So that is 2/3 of, what was VB? U times 7E plus 12 over 5. And that has to be greater than the magnitude of VA. And we know that VA is negative, so we just need to multiply that by -1. And then we'll be all right on that. So we can do 4U over 5 times 7E minus 3, just flipping the sign on that. So providing that comes out as being satisfied, then we're going to be all right. So let's cancel the U's, let's cancel the 5's. Let's get rid of that 2 with a 2 here and then multiply by the 3 to get a 6. So all in all, what is that actually leaving? We've got 7E plus 12 has to be greater than, well, this has come out a bit large, isn't it? 42E minus 18. Oh, right, okay, this is fine. So we've got 30 has to be greater than 35E. So E has to be less than 6 over 7. Right, so we've got bounds now on what E has to be. It's got to be less than 6 over 7. It's got to be greater than 3 over 7. All right, so they're giving us now that E is 4 over 7. Find in terms of M and U the magnitude of the impulse exerted on B by the wall. Right, okay. Right, I'm nearly out of space here. So let's hope this is going to be fairly quick. So the impulse is the change in the momentum. So the change in momentum, what did we have beforehand? Beforehand, we've got 4mVb. So that is 4m and then VB. So that's U over 5 times 7E, which is 4, plus 12. That's what we've got beforehand, and then afterwards, so we're going to have to add on the, because it's going to be negative going the other way, isn't it? So we can add on 4m, and then our 2/3 one. Yeah, it's just adding on the same thing but multiplied by 2/3. So u over 5, so I'll make that 16 now because we've already done that bit, multiplied by 2/3. So the reason I've added that on and multiplied by 2/3 is we know that the velocity of B after the collision is in the negative direction and multiplied by the coefficient of restitution. So when we do the difference between the two momentums, then we're going to be taking away a negative, which makes it a positive. So that is our change in momentum. That is our impulse. Okay. So, God, there's a lot going on here. We've got 4mu over 5. Let's take that bit out, which means we've got 16 plus 32 over 3. Just factorising all of that. So that is 48 plus 32, which is 80 over 3. Okay, so is this going to drop down to something a bit easier? Well, 5's go into 80, don't they? So we've got 16 times 4 is 64 over 3. 64 over 3 mu. And that is our impulse. So yeah, it's covered a bit of everything. This is why they like doing these. It's the classic collisions question. We've done the straightforward collision at the beginning. Then we've started looking at criteria, and in this case, the criterion that A has gone in the opposite direction after the collision. It's bounced backwards. Then we've got a second collision. So we've got all this stuff about keeping an eye on magnitudes and yeah, which direction things are moving in. And then we've wrapped up with some impulse. So this has got a bit of everything for the basics of collisions. Okay, we haven't got things hitting at oblique angles yet. That's the, I suppose, the main thing that's missing here. And okay, if you go a lot further, you're going to start getting things that are spinning around and rough surfaces and things like that. But yeah, let's not get carried away on all of this. So it's a really nice opener question, this one, for covering all of the basics.